Okay, so let's look at the three questions that you asked about 21, 22, and 24. 21, if you draw 4 chips without replacement, what is the probability that at least one of the chips are not white? And we have a bag with 5 red, 7 white, and 3 blue. So 4 chips, we want to know the probability that at least one is not white. Now I'm going to go to a page here for a minute. So let's realize to have at least one that's not white, we could have that the first one is not white and that the other 3 are white. We could have that the second one is not white and the other 3 are white. We could have that the third one, is not white and the other 3 are. And we could have that the fourth one is not white and the rest of them are. We could in fact have 2 that are not white. And I could keep listing. I mean, there are lots of possibilities where we have at least one that's not white. And when we see that we're listing all these possibilities out, we know that perhaps it is much easier to use the complement. So the complement of having at least one that is not white is to have all of them that are white. And I think you started out this way with your computation. So if we think of, I believe we're not replacing here. Let's see. Without replacement, yeah. Okay, so when we think about drawing a white chip, so a white chip, we're going to have 7 out of, it looks like we had 15 chips there. All right, we get a white chip, we don't put it back, we draw again, now we'll have 6 out of 14. And then, of course, for the third one, we're going to have 5 out of 13 and 4 out of 12. And I think you had this, but this is the complement. So we've got to realize to find the original probability that we were looking for, let's go ahead and get this as a decimal. I'll put it in my calculator. It is 0.0256. But this is the probability that we get all white chips, the complement of what we're looking for. So to get the probability of having at least one chip that is not white, we have to subtract this from 1, and that's going to give us 0.9744. So I think you were, you got this and forgot that you were finding the complement to get to your final answer there. All right, now let's go back to 22 and we'll, I'll go ahead and build the, whatever contingency table we're wanting for 22 first, and then we'll answer the questions. Okay, so for 22, we have that A is that basketball is their favorite sport, and B is left-handed. Now, the one that you had to answer that you missed on the quiz was G, but just in case, we'll just kind of walk through these very quickly. So the probability of having basketball as the favorite sport, if we go to the contingency data, so basketball is right here. There will be 13 out of 54 for that one. Let's go back. Probability B of being left-handed. We will have left-handers. We have 2 out of 54. Probability of not having basketball as their favorite sport. We just need to take 1 minus the probability we got in A, and the probability of not being left-handed, being right-handed, we'll take 1 minus the probability that we got right here in B. All right, so the probability of A and B. So we're looking at for people who had basketball as their favorite sport and are left-handed. So if we look up here, basketball as their favorite sport are these people right here. Left-handed is this column right here. They overlap right here. There's 1 person out of 54. All right, and then if we go back here, probability of A or B. Okay, so we need to use the formula for that. So let's remember the probability of A or B is going to be the probability of A plus the probability of B minus the probability of A and B. Probability of A, let's see, A was the basketball people, I think. So that's 13 out of 54. Probability of B was our left-handers, which I believe there were 2 of them. Whoop, there we go, 2 out of 54. And then the probability of A and B, left-handed and liking basketball, was 1 out of 54. And let's see, it looks like that's going to give us 14 out of 54. And of course, we would want to reduce that, but I'll leave that to you. All right, let's go back to our questions. Okay, so G, we want the probability of A given B. Okay, so the probability of A given B is equal to the probability of A and B over the second one in the notation, the probability of B, this one here. Okay, so the probability of A and B, we said from up here, was 1 over 54. Probably I should do this. And we want to put that over the probability of B, which was 2 out of 54. And if you think of in fractions, this is going to get flipped. The 54s are going to cancel out. We're going to get 1/2 or 0.5. All right, now I think the next one is our opposite conditional probability. Let's see. Yeah, the probability of B given A. So the only thing that's going to be different is that we're going to have the second one in the notation on the bottom, which will be the probability of A. So the top will still be the same, but the probability of A was 13 out of 54. And again, our 54s will cancel out. We'll get 1 out of 13 for that probability. So hopefully that will help you with 22. Now 24 I think is going to be similar. Let's take a look back here. Let's see, for 24 we need the contingency table for I and travel. So let me take a moment to produce that. So we want to find the probability of someone having brown eyes from our contingency table. So if we go over here, brown eyes is going to be, this is our row with brown, 26 out of 55 total. And then let's see, if we go back, probability of B, that they drive to school. Driving is right here in the second column. There are 38 people out of 55 who drive to school. All right, and then of course the complement, we're going to do 1 minus what we got in A. And for this one, 1 minus what we got in B. Now, the probability of A and B. We're looking for people with brown eyes who drive to school. So if we look back at our contingency table, here are the brown-eyed people. Here are those who drive to school. That row and that column come together right in this cell with 19 in it. It's 19 out of 55. And then probability of A or B, we're back to that formula. Now, I had written that formula out on the page, so let's use that on the page, but we'll fill in to this formula right here instead with the information from this one. So we need the probability of A. I believe A was our brown eyes. Yeah, so let's see. Probability of the brown eyes was 26 out of 55. Okay. And then we needed to add the probability of B. So let's see. B was driving people, so 38 out of 55. And then we need to subtract off the probability of A and B, which was 19 out of 55. And I'll leave that addition and subtraction to you. Now, I believe our next